So today we're going to talk about Bayes' theorem, and Bayes' theorem is basically a conditional probability theorem for inverting probabilities, and it's very simple. It's the last topic of the chapter on probability and statistics, and what we're going to talk about is sort of like the intuition behind it to justify the equation. And the theorem goes like this. The probability of A given B is the probability of B given A times the probability of A divided by the probability of B. And we're going to demonstrate it using first principles and using a probability tree. So let's say something happens and you have a probability tree like this, where you can have two kinds of events. You can have an A kind of event and a B kind of event. And let's say that there's three varieties of A kinds of events. There's A1, A2, A3. And let's say you wanted to ask, what's the probability that this particular event happens, where each of A1 and A2 and A3 may lead to B or B naught, or B or B naught. Each of them has that option. But you would like to know in particular, if this event occurs, okay, what's the probability that it occurred, particularly through this branch? And that's a very specific case of probability where we're sort of like going back in causation. We're saying that, okay, we already know B, but we'd like to know, okay, what's the probability of B knowing that, that's the probability of B happening after A, or B being caused by A, A1 in this case. What we're going to do is very simple. We're going to say it's going to be the probability of A, which is like, probability of A, and, probability of A1. And then we're going to multiply it times the probability of B, which is, in this case, is like 1/2. So it's like probability of, let's say, like B1 in quotation marks, and that would be like, in this case, that would be like 1/3 times 1/2. Why is that? Because, well, there's three ways that we can go in this branch, and there's A1, A2, and A3. So probability of A1 happening is always 1/3, and so this entire branch, branching from here to here, is going to be 1/3 times 1/2, because there's only two choices here. So this is actually the top part, and the top part is saying, okay, what's probability of B given A? And remember that in this case, we're really saying A1, like we're saying this particular A as opposed to other A's. But for B, we're saying the absolute value of B. And what do you mean by that? So we have to multiply this branch, and we have to divide it. We have to divide it by all the probabilities that B could have occurred. Because B could have occurred through A1, B could have occurred through A2, B could have occurred through A3. So all these different branches are possibilities. And so the absolute possibility of B happening is actually 1/6. Because B could have occurred like through this, or taking A1 would have led you to this. So you have to count 1, 2, 3, 4, 5, 6. So the absolute probability of B happening in general for this probability tree is 1/6. So you have to divide the whole thing by 1/6. And that's basically it. And if you look at this, this is the absolute probability of B happening in general. This is going to correspond to the probability of B given A. This is the probability of B given A. Let's see. Well, the probability, that's basically it. So the probability of B given A would be maybe 1/2, because we already know that A happened. So if I'm saying like B given A, I'm saying that A happened. So I'm saying I'm already here. probability of B given A. And in particular, in this case, we're looking for A1. So this would be like A1 in quotation marks. But it doesn't matter, like A is just the name of an event. And let's say this event is named A1 in this particular case, to differentiate it from A2 and A3 and whatever. And so the probability of B given A, we're already at given A, so we're already at A, so it's 1/2. So probability of B given A is actually 1/2. Probability of A is 1/3, and it's right here. Probability of B given A is right here. So this is why I put in quotation marks. Probability of B in quotation marks. It's really probability of B given A. Because it's not really the absolute probability of B, which would be 1/6 in general. And so the probability of A would be 1/3. Probability of B given A is 1/2, because given A, there's only two choices. And then you have to divide it by the absolute probability of B, which is 1/6, which is 1 out of like 6 possibilities. That's basically it. That's the sort of like intuitive conception behind the Bayes theorem. And here goes the theorem. Probability of A given B equals probability of B given A times the absolute probability of A divided by the probability of B. Thank you so much for watching the video.